Hi all, today we're going to smash 448, find all numbers disappeared in array, and it is another easy algorithm. I want to do like a set of easies and then we'll move on when I kind of feel like we're starting to get repetitive because we're becoming familiar with all of the various strategies that are used for the easy algorithms because they have patterns. Then we'll move on to some moderate and harder questions, which tend to be made up of combining these strategies. So once you master the easy algorithms, the medium ones and harder ones become easier as well. So let's get a good foundation. We're going to do this one today. I'm going to provide just one answer because one solution, because my video from yesterday was really long, 28 minutes, and I don't think anyone's going to sit through a 28-minute algorithm video. So I'm going to try to keep this one around 10 minutes and see how that does. I think that would be the ideal. Okay, so here's the description. Given an array of integers, some elements appear twice and others appear once. Find the elements inclusive that do not appear in this array. Could you do it without extra space and on linear time? You may assume the return list does not count as extra space. All right, so here is an example. We have this array. It is out of order. 1, 2, 3, 4. 3 and 2 are repeated. 5 and 6 are missing, and then we have 7 and 8. So the output, what we want to return, are the numbers that are missing in the series. And yeah, I think that's the only example we get. So let's get started. The first thing that we want to do is probably sort this array so that it's in order so we can easily detect where the missing numbers are. And we also want to get rid of the duplicates. So I'm going to start some pseudocode. So sort and get rid of duplicates in nums. And then we want to iterate over our sorted and unique numbers array. So iterate over this sorted and trimmed. Let's call it trimmed. Trimmed isn't a good word though because that entails there is an actual trim method. Sorted and pared down. So for each item in it, we want to check to see if current item that we're looking at is not the same as the next item or the value in the next position. Then we're going to want to push the item let's see, if current item is not the same as the next item index. So does this sorted array, then we're going to push the item into a results array. And that means that we actually need to create a results array. And we want to return results array. Now, we'll see in just a minute that we're missing one little step, but I think it's hard to see it until you build out the solution, then you see what the error is. So let's go ahead and code this out. And let's see, results or results? Results. Okay. And then we're going to sort the nums. So there are several ways that we can sort and also get rid of duplicates. And the way that I chose to do it is to use the new set constructor. So I'm going to create a new array with a new set constructor. And what this will do is it'll create a set of nums, and any duplicates will be gotten rid of. So if we want, we can just console log, sorted array, and run this. So here is our console log. So we got rid of the extra 3s and 2s at the end. So it kept these and it got rid of the second instance of them. But of course it's not sorted yet. So the next thing we want to do is sort it in ascending order. So we can take this same thing and just attach the sort method. And remember, the sort method takes two. Oh, I actually don't think I need to do that. Oops. I meant I don't need the return there. So the sort method takes two, A and B. It compares two items, A and B. And then we can return A minus B. And that should be in ascending, that should be in ascending order. So let's go ahead and run this code. And now we should have an array that's pared down and sorted. Oh, I think I see what I did. So I put in the curly braces here, which means that this is no longer, the return is no longer implied. So I would actually have to do return here, and then the sort should actually work. There we go. So now it's sorted. However, I could just make this simpler by taking out the word return, but also the curly braces. And now, because this is an ES6 fat arrow function, the return is implied. We don't actually have to put it in. Let's try that again. And now we should have our sorted array. Okay, our array is sorted and we've gotten rid of duplicates. Now we're ready to rock and roll. I'm going to get rid of this console log. And the next thing we need is to iterate over the sorted, over the array. So I'm going to create a good old for loop. Now I'm going to make a mistake on purpose here. And these will go up here. So then we need an if statement. If some conditions are met, then we're going to push the item into our results array. And there we go. One more up. And then we want to return results array. So let's do that right away. Okay. So we want to check and see if the current item is the same as the index plus 1. Well, why is that? Because our index starts at 0, and we want to check and see if this number here is the same as 0 plus 1. So if sorted array I is equal, or actually is not equal, because we want to find where it's not the case, to the index plus 1, then we want to push that I plus 1 into our results array. Okay, so the index the first time around is going to be 0. And we're going to compare to see if the 1 is the same as 0 plus 1, which it is. And then it will do the 2. The index is now at 1, so we'll see, is 2 the same as 1 plus 1? It is. 3. And then when we get to the 5, we're going to check and see if the index 4 plus 1, which is 5, is the same as 7. And it's not. It's going to fail at this point. So then we're going to push into our results array I plus 1, which is 4 plus 1, which is 5, right? Now, if we run this, let's go ahead and run it. It's going to go through, and this one is going to work just fine. So it's accepted for this one example case. But if we submit it, we'll see that there's an error. When we have an input of 1, 1. And the reason for that is because when we determine the sorted array length, if we use the sorted array, remember we took out some duplicates. So the length of this array is actually different from the length of the nums array. So the first thing that we need to fix is that we actually need to go through the length of nums, I think. Actually, let me try something. If we take the sorted array and we basically insert the number 5 into it at the appropriate spot, then that is going to grow the array by 1. And when the for loop goes through its next iteration, it will then know that the length has changed, because we're calculating the length each time we go through the for loop here. And that way, basically, it won't move to the 8 until it catches up with a 7, which is what we want to do. So it doesn't find 5, so we're going to insert 5, and it's going to then go on to check 6. 6 is also not going to be there. So it's going to insert 6, and then it's going to check 7. So we actually need to insert the numbers into our sorted array so that the length stays, so the numbers are still in order, so we don't get out of order. So let me do that. I'm going to add some pseudocode. We want to add missing number to the array. And let's say if this fixes it. Yeah, so we're going to use the splice method. So, oops, we want sorted array. We want to use the splice method because that allows us to insert into our array a specific item. So we're going to splice at I. So if we are, whatever position we're at, that's where we want to do the splicing. We don't want to take anything out, which is the 0. So that's how many things you take out. But we do want to insert I plus 1, which would be, the 5 or the 6. So now if we run this, and now we're going to submit it. And we still have this wrong answer. And that's, I think, because we're expecting to get 2 here, But once we sort the array, there's only one in the array, so the sorted length is just one, and it basically quits before we can add and go through the loop again. So we do need to change this to the array of nums, the length of nums, I think it is. Let's see. Yeah. Because eventually we're going to get to that length. There are going to be two numbers missing there. So let's go ahead and submit this and see if we pass that issue. There we go. So now we are good to go. It took a long time. 836 is pretty long, and it's only 25, let's say, % better or faster than other JavaScript methods. The description, it is linear, so it is linear time. So we did do that. We did, however, create this array. So we did use extra space to create this result. I guess another approach would be, instead of splicing it into the array, what we could do is slice out the number as soon as we judge it. So 1 is there, okay, great, we'll get rid of 1, we'll start with the array at 2. And that way what we're going to end up with, if the 5 and the 6 are not there, we're going to insert it into the array, and we're going to get rid of the other things that are there. So we could do this backwards and say, if it is there, then slice it out and then return the nums array, which I guess slice is not destructive, so we could use splice to remove it, and then the array, the original array, since splice is destructive, would reflect any numbers that were there in the right positions would be taken out. Any numbers that were missing would be inserted. So by the end, we will transform the same nums array into 5, 6 in this case, which is what we want, or the other in any of the other cases. So that maybe would have been a better approach. We could try that next, but I'm going to leave it to you to try that, and tell me down in the comments how it went. And maybe I'll come back to this problem in a few days and try that next result. And we can compare different solutions. So if you like this video, say hello to me in the comments down below. I am a new YouTube channel, and I'm looking forward to hearing from those of you who are starting to find me. If you like what I'm doing, go ahead and subscribe and hit the little notification bell so that you'll know when I put up a new algorithm. Okay, see you next time. Bye.